Hello, today we are going to discuss the topics like concept of average, objective and its requisites, concept of central tendency and measures of central tendency or types of averages. So let's start with the concept of average. Why we need average? What is mean by average? So in day-to-day life we come across the situations in which we handle the data with large volume. In such situation, it is impossible to draw any conclusion about data only by visualization. Hence we need some tools to summarize the data to find a single value. This is what a concept of average. Let's have one example to understand these lines. Marks in statistics out of 100 of 10 girls from class A are as given below. So we have given a data. I have taken a data of only 10 observations just to explain, but in real life situations, data are in large volume. In order to discuss the performance of a girls, in terms of marks, then it is impractical to read each and every individual's marks. Instead, what will I do? I will find one representative value of data, that is average. So how can I find the average? So let's try to find the average value. So how will I find average? That sum of all observations divided by total number of observations. So sum of all observations means the observations are 95, 68 plus 42 up to 54 divided by total number of observations, that is 10. So what is sum of all observations? That is 653 divided by 10 is equal to nothing but 65.3. So using this single value, I can easily interpret that performance of a girls from class A in terms of marks is above average. Averages facilitates comparison also. Let's have one example. Suppose if I want to compare the marks of a girls from class A and from class B. Comparing these individual marks is difficult, but it is more convenient to take an average of marks of a girls from class A and from class B. Similarly, we will find sum. So what is the sum? I will write here. And then we will find average by dividing total number of observations, that is 5. So I got the average of girls from class A is 67.4 and average marks of a girls from class B is 56.4. So clearly if you compare these two values, you can easily interpret that performance of a girls from class A is better than class B. Two more points about averages are: averages is a value around which most of the observations are clustered, and graphical representation is also used to summarize the data, but it gives approximate value which is not sufficient for further statistical analysis. Hence we go for the concept of averages. So the next topic is objectives of averages. The first one is to obtain a single representative quantity for the entire data and to facilitate comparison, as we have discussed in this video. So next is requisites of good averages. Obviously it should be easy to understand and simple to calculate. Then it should be rigidly defined. So what is mean by rigidly defined? So it means it should be defined in such a way that it has unique interpretations. It should be computed by well-defined algebraic formula. So all get same answers for averages for the same figures. There should not be any biasness of the investigator. Next one is it should be based on all observations. It means average should have impact of each and every observation. So if any one of the observation is omitted, the average itself get changed. Next point is it should be capable of further mathematical treatment so that utility is also enhanced. I will give you one example. In finding a value of variance, we need to find arithmetic mean first. It means arithmetic mean is used for further mathematical treatment. We are going to see the concept of variance in the next videos. Next point is it should be least affected by extreme observations. Let's try to understand this using example. Suppose I have a data like 2, 5, 6 and 9 and I want to find the average. Then sum of the total observations is 22 and divided by total number of observations is 4. So the average is nothing but 5.5. Let's have one another example. Suppose I have a data like 2, 5, 6, 9 and 100. So the sum of these observations are 122 divided by total number of observations are 5 and here is the answer, that is 24.4. If you notice that here we got the answer where the observations are clustered around it, but in that case we got the value in such a way that not even single value is around it. This value, so what we interpret that this value is interpreting the data. This value is misinterpreting the data. Average is not really typical as it is getting affected by extreme observation. So here is the point that it should be least affected by extreme observations. Next point is it should possess sampling stability. It means let's have one example. If I pick five different groups of students from college and I want to compute average height of each group, then we expect to get approximately same value for each group. Obviously, there will be difference in values for different samples, but the difference should be less. It means it should have sampling stability. More sampling stability results in more appropriate interpretations. Our next topic is central tendency. The word central tendency itself expresses its meaning that most of the observations are tends in central part of the data. Most of the observations are clustered in central part of the data. This property of observations is described as central tendency. A representative value from the central part is referred to as an average or measures of central tendency. Let's try to understand this line. This is the bell-shaped curve. Frequency curve is bell-shaped. Here, what we read just most of the observations are clustered in central part of the data. Yes, most of the observations are clustered in central part of the data, and representative value from the central part is nothing but average or measures of central tendency. So let's try to understand the nature of this frequency curve. Initially frequencies are small in magnitude. Later on it increases. It reaches to the maximum in the middle part of the data and then again it falls down. Let's have one example to understand the concept of central tendency. Consider an example from day-to-day life. You will experience that in class there are very few students having a marks less than 20 or 30. Let me plot marks here. Uh, So there are very few students having the marks in range 10 to 30 or 20 to 30. Similarly, there are very few students having the marks in range 80 to 100. But there are approximately maximum students having the marks in the range of 50 to 70. There is some mistake in graph. That is, most of the marks are clustered, most of the range of the marks is clustered in the central part of the data. This type of many examples you will notice in real life, like average income. Middle class people are maximum than higher or lower class. Similarly, average profit, average run rate of a team in day to day, in one day, are also examples of central tendency. So this is what the concept of central tendency. So our next topic is types of averages or measures of central tendency. So following are the types like arithmetic mean, simple and weighted arithmetic mean, median and mode. We are going to discuss these topics in detail in the next video. If you have any doubt till now so far, comment me in the comment section. Thank you and all the very best.